Welcome back, Grade 6. Today we are starting Nelson Math, Chapter 4, Are Getting Started. Our goals for this chapter will be to use mental math, as well as paper and pencil, to add and subtract whole and decimal numbers. We're going to estimate sums and differences of whole and decimal numbers. We're going to use addition and subtraction to solve problems and justify our choice of calculation. We're going to say why we chose that method of calculation. And of course, it must make sense. And here's our review from previous times. We're going to be asked to use mental math. So for this, use mental math, we have a couple of different ways. I'm not going to do all four of them. But if you look over here, 1a, it's 25 plus 76. We have a few different choices. So I can take the 25 plus 76 and rename it into 25 plus 75 plus 1. I've renamed the 76 to 75 plus 1. 25 plus 75 we know is 100, and then add 1. So our sum is 101. I can also do it this way. I can also take all of our tens, just look at the tens digit. So this tens digit is a 2, signifying 20. This tens digit is a 7, signifying 70. So I've decomposed the number into 20 plus 70. And then I can go back and add whatever was left over. So instead of saying 25 plus 75, plus 76 rather, I've changed it into 20 plus 70 plus 5 plus 6. So add up the tens first, which is 90, and then add up the ones, 11, and it's 101. Both of those methods are completely valid. We could have also, for example, I didn't write this one down, but you could have added the ones first if you wanted to. So let's go back here for a moment. We can say that 6 plus 5 is 11. 70 plus 20 is 90. So 11 plus 90 is 101. That is also a valid way of completing this question. For B, 99 plus 199. So we are going to change our 90. This is one way, once again. There are many different ways of doing this. You could use the methods we used for A if you want. I'm showing you a slightly different method. We could change our 99 to 100 and our 199 to 200. So that's 100 plus 200 is 300. That's pretty easy to do, but we added a number to our 99 and we added a number to our 199. We added one here and one here to get our new numbers. So we must subtract those numbers to get to our exact answer. Look at C now. It's 1000 minus 895. Our first method would be change the 895 to 900. So one way of looking at this is 1000 and then remove 895. But we're going to remove 900 first. So 1000 minus 900 is 100. But we did not want to remove 900. We only wanted to remove 895. So we took off 5 too many. So we have to add it back. And here it's 105. Of course, we could go back and check. 105 plus 895 is 1000. Another way that we could have done this is using the difference method. So we could look at this question as saying, how far is it from 895 to 1000? So we've used number lines before. We're going to ask you to make a number line in your head. I've made it numerically over here. So to go from 895 to 995, that's exactly 100. So that's 100 steps, but we're not quite at 1,000 yet. So we have to go from 995 to 1,000. That's 5 more steps. So we took 100 steps to go from here to here, and then 5 more steps to go from here to here. So that's a total of 105 steps. Our last one, 233 minus 99. 233, I've changed the 99 to 100. And if we carried this one out, it would be 133. But I took away one more than I should have, so I have to add it back. I could have also changed this question. I didn't write it down, but we could have changed this question to 234 minus 100. The numbers are different, but the difference is the same. So to put it in a different way, the, the distance from 1 to 6 is 5 steps. The distance from 2 to 7 is 5 steps. The distance from 3 to 8 is 5 steps. All the differences are exactly the same. I'm just moving how I'm showing my difference. So that's number 1. Let's move on to 2. So for number 2, we have here, right here, use estimation to determine if each calculation is reasonable. Correct any unreasonable calculations. It's important to recognize that this question is not asking us to find sums and differences. You can get a calculator for that. Go ahead and you can carry these out and see if the number is correct. But we should be able to do it in our heads in much less time than it takes to use a calculator. So we're not asking once again if it's exact, we're asking if it's reasonable. Let's look at 2a. 2,365 plus 4,869. I rounded those numbers. I rounded the first number to 2,000. I rounded the next number to 5,000. So 2,000 plus 5,000 is 7,000. So yes, 7,234 is reasonable to our estimate of 7,000. Let's look at B. 5,497, 3,476. We don't always have to round to the nearest thousand. Sometimes we can round to numbers if it makes sense in our heads. So our first number is very, very close to 5,500. So I've chosen to round it to 5,500. Our next number is 3,476, which is again pretty close to 3,500. So I've rounded it there. If I just add up the thousands here, it's 5,000 plus 3,000, that's 8,000. But then add up my next 1,000. 500 plus 500 is 1,000. So 8,000 plus 1,000 is 9,000 for our estimate, but our calculated answer in 2b is 7,973. So we know this is definitely wrong. I'm going to give you an example of why sometimes some students might think this is correct. If they use our rounding rules and they round the first number to the nearest 1,000, our rounding rules tell us that this should be rounded to 5,000. If we use our rounding rules for this number and we round to the nearest 1,000, this number would be rounded to 3,000. But there is one thing you may have noticed, and that would be this number is really close to the middle. This number is really close to the middle. So if we round both of these numbers downward, our answer would be, our estimate rather, would be way, way too small. So some of you might look at this and say 5,000 plus 3,000 is 8,000. Yeah, this is pretty close to 8,000. But we rounded this way too low. One thing we could have done is what we did, where we rounded to the nearest 100. However, we could have also rounded one up and one down because they're so close to the middle. For letter C, 6,238 minus 1,639. We're rounding this to 6,000 minus 2,000. We use our standard rules here. The answer is about 4,000. However, here, we're about 1,500 off or 1,600 off. So this is way, way off from our estimate. So this is not a reasonable answer. And letter D, 8,000 minus 1,567. For this one, if we rounded this, our second number, to our rules, we would end up getting 8,000 minus 2,000 is 6,000. But that's a little bit far off. I think we can do better. We can round our 8,000 and leave it like that, but we can round our 1,567 to 1,500. Now we can take away 1,000 and then take away another 500, which gives us 6,500. Here's number 3. For these questions that we're reviewing, you're free to use, of course, any of the systems that make sense to you. Here's 3a. We are adding up this set of 3 numbers. For this, the standard algorithm works just fine. So if you would like to start off at the right, and for example, 4 plus 6 is 10, plus 4 is 14. You could put the 4 down here and carry the 1, put the 1 up here. This method will work every time if done correctly, but there are some things I would like to remind you of. When we did 4 plus 6 plus 4 is 14, and we put the 1 up here, that is not a 1. That is a 10. So when we add up this column here of our tens, it's 1 10 plus 9 tens plus 8 tens plus 3 tens. We will call it sometimes 1 plus 9 is 10 plus 8 is 18 plus 3 is 21, but that's actually 21 tens. And the little 2 that we put up here actually represents 200. So let's do that now. So here's our sum, and to go through it, 4 plus 6 plus 4 is 14. Put the 4 here, carry the 1. 1 plus 9 is 10, plus 11 is 21. Carry the 2. 2 plus 3 is 5, plus 1 is 6, plus 5 is 11. The 1 down here, carry the 1. And then 1 plus 4 plus 2 plus 6 is 13. So this standard algorithm works every time, provided you use it correctly and you know what we're talking about. Of course, there are many ways you can do this as well. For 3b, that's this one right here, we can start off by once again using our standard algorithm, or the other option that we have would be saying 7 ones plus 1 1 is 8 ones, which I'm putting right there. And then beneath it, we can work on the tenths. 5 tenths plus 7 tenths is 12 tenths. We know that 10 tenths is 1, so 12 tenths is 1.2. So 8 plus 1.2 equals 9.2. That method will also work every time if done correctly. For this one right here, 2000 minus 757, we could once again use our standard algorithm. That will work every time. So for example, 0 minus 7, you can't do it, so you have to borrow and so on all the way down until you get to the 2. Cross out the 2, put the 1. If you would like to use that, that's great. Go ahead and use it. But I am going to show you one other thing that you may want to use or make use of. I took my 2000 and I changed my 2000 to 1999. So I made it 1 less. My 757, I changed it to 756. Also 1 less. If you think of a couple of minutes ago when I told you about subtracting, 7 minus 2 is 5, and 8 minus 3 is 5, and 9 minus 4 is 5. I'm keeping the distances between my two numbers the same. So the distance from 757 to 2000 is the same distance as 756 to 1999. So this difference is now significantly easier to find because I'm not borrowing anything. Let's carry that out now. So if you look here at how we subtracted, all of our top numbers are all bigger than our bottom number. So 9 minus 6 is 3, 9 minus 5 is 4, 9 minus 7 is 2, and here's our 1,243. We could do a similar method with this one, or you could use our standard algorithm. There are lots of different ways of doing this. See how many you can come up with. If you wanted to use our standard algorithm, which we didn't do over here, we can do that one now. And through our magic of editing, I was able to show the standard algorithm. So we can't do 5 minus 8. So we take 10 we take, or in this case, 1/10, and now we have 1/10 and 5/100ths. So 15 minus 8 is 7. We can't do 5 minus 8, but we can borrow. So we can have 15 minus 8 is 7. And then 1 minus 0 is 1. So this is using the standard algorithm to subtract decimals. When you're subtracting decimals or adding decimals, you must keep every column lined up. Just the same way you do when you're adding tens and hundreds and thousands. Whenever you have, regardless of how many numbers are after the decimal or before the decimal must be lined up along with your ones and tens, but also your tenths and your hundredths. Otherwise, you might be adding 6/10ths to 5/100ths, but it should have been 6/10ths plus 8/100ths, for example. So you must always keep them lined up. Thanks, everyone. Have a good day.